students. So this is 12 to review, and this is all about conditional probability. And also we're going to go into a little bit about how we know that two events are independent if there's a given conditional of some sort. So today, let's look at the conditional probability formula right here. So conditional probability, this says that the probability of A and B occurring is equal to the probability of A occurring given that B occurs, multiplied times the probability that B occurs. Now, I know that might look a little confusing, but when you look at a table, it's actually quite a little more straightforward from the table, and I'm going to help you using the table. So a conditional probability, the probability that event A will occur given that another event B has already occurred. So that's what this is saying. This is a conditional probability. Now, sometimes we rewrite it to say that the probability of A given B is equal to the probability of A and B occurring divided by the probability of just B occurring. So I'm going to show you how the table makes it a little easier to do this, although we can do it both ways. So here's a chart of number of times students visit the tutoring center and whether they're a full-time student or a part-time student. And notice the totals. That's nice to have. Sometimes you're given a table without totals, so you want to write those totals in there. And then this total, 58, should be the same as this total, because this is the total number of people that were involved in this. So the probability that a student will visit the tutor center one or fewer times given, that's that given part, that they are a full-time student. So let's do this, the probability a student will visit the tutor center one or fewer times. Let's call that event A. And this given that their full-time student will be event B. If you look at the chart, so it's given that they're a full-time student, you can just look at this row right here of full-time students. And you can see that there's a total of 45 students, right? So we're given that our full-time student, and we want to know the probability that they'll visit one or fewer times. Well, that would be this. So you would just take the probability of A given B is from the table, all you have to do is 12 out of 45. If I want to use my formula, I'll show you what happens. So the probability of A and B happening, meaning they're visiting the tutor center and they're a full-time student. So that's 12 out of a possible 58. That's what that number is on top. The probability of A and B happening out of, whoops, I don't know why I wrote that down, 58. Okay. Now, the probability that B would happen, and B is just that they're a full-time student, that would be 45 out of 58. Now, when you take this and divide it by this, that's what we're doing over here, we flip this over, right, 58 over 45, and look what happens. Those two cancel out, and you end up with the 12 over 45. Now, sometimes you don't have a chart, and so this might be easier to do. But when you have the chart, it sure is a lot easier just to use the chart. It's up to you. You decide what you want to do. Here's another one with a chart. It says, what's the probability that a patient did not exercise given that the patient did not catch a cold? So did not exercise, we'll call that A. Did not catch a cold, we'll call that B. So given they did not catch a cold, so I would look here, well, wait a minute. there's no total. So I'm going to go ahead and total that 32. This one's 18. Go across. That's 38. And go across there. That's 12. So it looks like if I added those both up, I would get 50. Nope. 3, 4, 5. Yep, I did it. Okay. All right. So now I'm just going to use the chart. And let me see if I can, yeah. So it says, what's the probability that the patient did not exercise given that the patient did not catch a cold? So the first thing I do is the patient didn't catch a cold. So it's this right here. And then the patient did not exercise would be this one. So it'd be 2 out of the 32 possible cases. And you get 1 over 16. Again, you could use the formula. If you write this formula out enough, you'll memorize it, but otherwise write it down in a handy place where you have a formula card. You know how to do it. Got to know how to use it. So if I want to know the probability that he did not exercise given that the patient did not catch a cold, I would want to know the probability of did not exercise and catch a cold out of the whole population. So did not exercise and did not catch a cold was 2 out of the whole population. And then the probability B that he did not catch a cold, that would be 32 out of the whole population. See how it simplifies down? Again, it simplifies to 232, which is 1 over 16. Now this one, they didn't give us a chart, but I think you could make a chart for this one. We have a fundraiser. Participants asked what's inside an unlabeled can for a possible prize. If 2 crates of cans to choose from, each having a mixture of vegetables and soup, what's the probability that the selected can came from the left crate, given it's a vegetable, in the following situations? So left crate, given it came from the left crate, that's going to be my A, and that it's a vegetable is going to be my B. So I could use this formula, and I could say, and here's the particulars. The left crate has 2 vegetables, 8 soup. The right crate has 7 vegetables, 3 soups. And the first thing I would have to know is the total number of cans, because I'm picking one randomly out from either of those crates. So the total number would be 10 here and 10 here would be 20. So the probability that it's a vegetable and from the left would be 2 out of my total 20 cans. Now remember, we're looking for the probability that it's a vegetable. That's B. Well, you have to look at all your vegetables. You've got 9 out of the 20. Once again, you can just divide those. 2 over 20 divided by 9 over 20, multiplied by the reciprocal, and you would get 2 out of 9. That's one way to do it. Another way to do it is to make a chart. And if you can make the chart and it's no problem, I would go ahead and do that. So you have the options of a left crate and a right crate and a vegetable and a soup. And then you would put your information in here. The left crate has 2 of these, 8 of these. The right one has 7 of these, 3 of these. You would total them up because you're going to need those totals for the column or the row. And then you'd have 20 altogether. So if I was just looking from the words, what's the probability that a can came from the left crate, given that it's a vegetable? So the given part is this one right here. So this is going to be your bottom number. Given that it's a vegetable goes on the bottom. And then the probability that the left would be the 2. So that's how you do it from that way. Here's another one. Again, they don't give us the totals, but this time they're not really asking straight up what the probabilities are. I think the problem might ask you that eventually, but they're wanting to know if they're independent or dependent. So here we need another definition with a formula with it. So two events are independent if the probability of A given B is the same thing as the probability of A. In other words, B does not affect what happens to A. And the reverse also has to be true. The probability of B given A is equal to the probability of B. So B happens no matter what A is. And then B and A cannot be zero. So I'm going to go ahead and total these up because I just like having totals. And then I don't have to think about it as I go. And then it looks like if I did it right, they both, the column and the row adds up to 81. So there's 81 total students that were involved here. Now to decide, I think the computer, if you did this on Excel, the computer decided which one was A and which one was B. But you know what? It doesn't matter. You can choose whichever one you want. And as long as you find one that's not true, then you know it's not independent. So if I want to do maybe I want to do sophomore is my A and robotics is my B. So the probability that I have a sophomore, given that he takes robotics, has to be the same thing as the probability that he or she is a sophomore. Well, let's check that out. We're going to check this out. So sophomore given robotics. Remember, if it's given to you, you're going to circle that total of the robotics given to you. So I know that 40 of my students, 18 are sophomores. So 18 are sophomores given that they're taking robotics. So 18 of sophomores, of all the robotics students, 18 are sophomores. Okay. Now, what's the probability that they're sophomores? Well, now I'm going to look here. I've got 38 of those guys out of 81. Are those two the same? You could put them in a decimal and figure it out. This simplifies. I was just looking for my calculator handy. You know how that goes. My calculator, and I found that they were not equal. So as long as one of those things is not true, that you can say they're dependent. All you need is one situation. Okay, let's take a look at this problem. I think this one is a little more challenging because they gave us more information than we really needed. And that always makes it kind of hard to maneuver through that. So it says, what's the probability that a high school member selected at random, so we'll call that high school member from our A group. Oh no, this we already know they're a high school member, so that's what's given to me. What's the probability that they're on the swim team? So there's a bunch of high school kids at this rec center, and I want to know what's the probability that they're on the swim team given that they're a high school student. So I would rearrange that. So the probability that they're a high school student and on the swim team divided by the probability that they're a high school student. So you would have to look at the totals here. And I would say this was probably one of the most challenging ones because they gave us more information than we needed. So if you look at what's the probability that their high school and swim team? Well, how many kids are on the high school swim team? You got 45, right? Out of the total number of people that were in the gym. Now, what's the probability that they're a high school student? Well, there's 200 out of the total number, whoops, in the gym. Okay, again, these end up canceling out and you get the 45 over 200. And I know both of those are divisible by 5. That goes in there 40 times. That's about as simple as it'll get. Now you could make the chart. I found that the chart wasn't as helpful for this, but either way, you can do it either way. And lastly, we got some more events we're looking at to see if they're independent. And I thought there's a little bit of trickiness going on here. You have to have this rule, has to be satisfied. So they're giving us, where B given A is 1/3, so this is 1/3. And then B given probability of B is 5/9. Well, you can see that that's not the same. So it's not this one. Now this one's a little, you kind of have to go back to your other situation here. The probability of A and B, I should have left it up there, is the probability of A given B times the probability of B. All right, so because they're giving us this right here. They're giving us this, 0.075. And if it's independent, what did we say? We could just, if it's independent, this value right here is the same thing as the probability of A, which is 0.3. And then, so we're asking a question here. The probability of B is 0.25. So if you multiply those out, you would get 0.075. And make sure you get your decimals in the right place. Because I know I get 0.75 and then I have 3 decimal places. So make sure you do that. So that one would work. Now I thought this was interesting. You select a student at random as a junior and a student selected at random as a freshman. Well, the problem with that is, I want to say junior given that he's a freshman. Well, that can't happen, right? So they're 2 separate groups. They can't even be in the same group. So those would be occurrences, those mutually exclusive occurrences, right? They can't happen at all. So events A and B, where probability A is 0.4 and probability B is 0.3, and then when I multiply them together, do I get this? That's the question. And in your head, you might do it real quickly. You know that's 12, and then you 2 decimal places over. So they just got off by a decimal point. So that's kind of important that you make sure you just do that accurately. And then the last one says a student selected at random has a backpack. Given that a student has brown hair. And this one, you really don't have any numbers to work with, but you can see that the brown hair should not affect the backpack probability. So it shouldn't matter whether they have brown hair or not. So that would be that one. Those are a little harder, a lot of thinking going on there. But I appreciate, keep looking back through these, try your Math Excel problems, and I did put some extra problems on there, and that should help you decide which ones you need more work with or which ones you hopefully gain some confidence with. Thank you.